Hey everyone. So today we're diving into something that feels just immense and unpredictable, right? Landslides. These massive shifts of Earth that can literally reshape a landscape in a blink. But what if I told you that blink isn't really a blink at all? We're going to look at how a totally new way of seeing things, plus some seriously cool tech, is changing everything we thought we knew about these disasters. You've heard this phrase a million times, I'm sure. After almost any big landslide, whether it's Genting or Cameron Highlands, this is what you hear on the news. It just happened so suddenly. It perfectly captures that feeling of shock, you know? Like it was a complete bolt from the blue. But was it really? That's the question at the heart of all this. What if these huge, catastrophic events aren't sudden at all? What if they're just the final, explosive chapter of a story that's been quietly unfolding for years, completely hidden from sight?
Yeah, that brings us to what you could call the sudden disaster myth. See, what engineers and scientists now understand is that the ground, it almost never fails without giving some kind of warning. The huge, dramatic collapse that we see on TV, that's just the very last act of a very, very slow play.
Here's the truth of it. The soil and rock right under our feet can be in a state of failure for years, sometimes even decades, before a single crack shows up on the surface. It's this hidden process, a slow-motion weakening, that's happening on a scale that our eyes just can't pick up.
So how does this invisible failure actually happen? Well, it all starts with something called creep movement. We're talking about a tiny, almost imperceptible shift of just a few millimeters a year. But over time, that slow creep builds up internal stress, or strain, which starts to weaken the soil structure from the inside out. All of this is happening where nobody can see it. And the very last thing to show up, that's the first thing we'd notice: visible cracks.
And this right here is the key. Those cracks aren't the start of the problem. They're a symptom that the whole failure process is already well underway. So relying on just looking for cracks is kind of like calling the fire department after your house has already burned to the ground. It's just too late. So you have to try and picture the Earth's surface in this kind of invisible, slow dance. All these hillsides, dams, and slopes are constantly shifting and deforming in these super subtle ways, responding to gravity and water and all sorts of pressures. And that is the fundamental challenge, right? For all the engineers and safety officials out there, if the most critical, most dangerous phase of a landslide is completely invisible to the naked eye, how on earth are we supposed to get ahead of it? How do you go from just reacting to disasters to actually, preventing them? Well, the answer, and this is pretty incredible, comes from space. We actually now have a technology that works like a detective on a planetary scale, and it can spot these tiny, telltale movements all the way from orbit. It's called INSAR, and yeah, that's a mouthful. It stands for Interferometric Synthetic Aperture Radar. But what it really does, in simple terms, is use radar signals from satellites to create these incredibly precise maps of the ground. Honestly, it is an absolute game changer. Probably the easiest way to wrap your head around how INSAR works is with a little analogy. Just imagine the ground below us is a giant, stretched-out piece of cloth. Okay, so you have satellites with this radar tech passing over that cloth again and again, beaming down signals. By comparing the signals from each pass, INSAR can detect the most minuscule shifts or wrinkles that are forming on that cloth. Those wrinkles are the very early signs of the ground deforming. And the precision here is just mind-blowing. We're talking about an accuracy of plus or minus 2 to 5 millimeters. That is less than the thickness of a coin. From space, this technology is literally making the invisible visible. But here's where it gets even cooler. Because satellites have been gathering this data for years, we can basically go back in time. We can pull up a decade of historical data and see exactly how a specific slope has been behaving long-term. We can spot the patterns of movement that scream future risk. All right, so let's bring this space-age tech back down to Earth. How is this actually being used? Well, a place like Malaysia, with its combo of unique geology, tropical weather, and super-fast development, is the perfect place to use INSAR monitoring. So using INSAR, experts can start to pinpoint these hotspots. In a place like Selangor, the big concern is all the intense development on cut slopes. Over in Perak, it might be the big dams and other massive structures. And then along the east coast, you've got that dangerous mix of hilly highways and those powerful monsoon rains. And this brings up a really key point, a huge misconception. We always blame the heavy rain for causing a landslide. But what INSAR data shows us time and time again is that in many cases, that slope was already unstable. It was already slowly moving. The downpour was just the final trigger, the straw that broke the camel's back.
So, what does having all this data actually mean in the real world? It means we can finally flip our whole approach to this problem. We can stop being reactive and start being genuinely proactive.
I mean, just look at this slide. It lays out the shift perfectly. On one side, you have the old way. You wait for cracks or other danger signs to show up. Then you scramble an emergency response. And on the other, the new proactive model. You use INSAR to watch for that invisible movement, which lets you prioritize areas, plan ahead, and maybe prevent the disaster from ever even happening.
Now, to be super clear, INSAR doesn't replace engineers or on-the-ground investigations. Not at all. Think of it more as a powerful focusing tool. It helps them manage their limited time and resources. It answers that critical question: out of thousands of slopes, which ones are actually moving and need our immediate attention?
And as incredible as this all is, we're really just scratching the surface. The ultimate goal here is to move beyond just detecting movement and get to a point where we can accurately predict failure. The next wave is already coming. It involves analyzing INSAR data over time to spot when that slow creep starts to accelerate. It means feeding all this data into AI to find complex patterns we might miss. And it means fusing it with other info, like rainfall forecasts or even traffic data on highways, to create a system that is truly predictive.
You know, the ground beneath our feet is never truly static. It's always moving, always shifting. But now, for the first time ever, technology is giving us the power to actually see that hidden movement. We can finally learn from a slope's past behavior before it fails. And really, that leaves us with one final big question. For decades, these disasters felt random and unavoidable, but now we have the tools to see them coming, sometimes years in advance. So the challenge isn't about seeing anymore, it's about acting. Now that we can get a glimpse into the future, how are we going to choose to change it?